Using the definition of the unit circle, derive the identity sine squared x plus cos squared x equals 1. Why is sine squared x plus cos squared x equals 1 called a Pythagorean identity? Draw a right triangle within the circle as shown. Cos x equals a over 1. This becomes a equals cos x. Sin x equals b over 1. This becomes b equals sin x. Using the Pythagorean theorem, we get a squared plus b squared equals 1 squared. Replace a with cos x and replace b with sin x. This gives us cos squared x plus sin squared x equals 1. We call cos squared x plus sin squared x equals 1 a Pythagorean identity because it is derived from the Pythagorean theorem. In part B, verify that sin squared x plus cos squared x equals 1 is an identity using 1. X equals pi over 6 and 2. X equals pi over 2. Begin with pi over 6. Rewrite the identity sin squared x plus cos squared x equals 1. Plug in pi over 6 for x. Sin pi over 6 equals 1/2, and cos pi over 6 equals root 3 over 2. Square the terms. Combine the fractions. The result is 1 equals 1. The left side and right side are equal. Now we'll try pi over 2. Rewrite the identity sin squared x plus cos squared x equals 1. Plug in pi over 2 for x. Sin pi over 2 equals 1, and cos pi over 2 equals 0. The result is 1 equals 1. The left side and right side are equal. Note that the term verify is used to check that something is true for a specific case. The term prove is used to show that something is true for all cases. In this example, we verified sin squared x plus cos squared x equals 1 for the specific cases x equals pi over 6 and x equals pi over 2. However, our results for these two cases make no guarantee that sin squared x plus cos squared x equals 1 works for other x values as well. In part C, verify that sin squared x plus cos squared x equals 1 is an identity using a graphing calculator to draw the graph. Make sure the calculator is in radian mode and use the settings shown. Now draw the graph of y equals sin squared x plus cos squared x. Next, draw the graph of y equals 1. The graphs of the left side and right side are identical, so sin squared x plus cos squared x equals 1 is an identity. Note that graphing the left side and right side of a statement is a verification, not a proof. There is always the chance that the graphs just look similar without actually being identical. Now we'll move on to part D. Using the identities sin squared x plus cos squared x equals 1, derive 1 plus cotan squared x equals cosecant squared x, and tan squared x plus 1 equals secant squared x. We'll begin with 1 plus cotan squared x equals cosecant squared x. Rewrite the identity sin squared x plus cos squared x equals 1. Divide both sides by sin squared x. Simplify. Cos squared x over sin squared x equals cotan squared x, and 1 over sin squared x equals cosecant squared x. This gives us 1 plus cotan squared x equals cosecant squared x, completing the derivation. Now we'll derive tan squared x plus 1 equals secant squared x. Rewrite the identity sin squared x plus cos squared x equals 1. Divide both sides of the equation by cos squared x. Sin squared x over cos squared x equals tan squared x, and 1 over cos squared x equals secant squared x. This gives us tan squared x plus 1 equals secant squared x, completing the derivation. In part E, verify that 1 plus cotan squared x equals cosecant squared x, and tan squared x plus 1 equals secant squared x are identities for x equals pi over 4. Begin by verifying 1 plus cotan squared x equals cosecant squared x at x equals pi over 4. Rewrite 1 plus cotan squared x equals cosecant squared x. Plug in pi over 4 for x. Rewrite the cotan and cosecant ratios in terms of sine and cosine. Both cos pi over 4 and sine pi over 4 equal root 2 over 2. For each fraction, multiply the numerator by the reciprocal of the denominator. Simplify. Simplify further. The result is 2 equals 2, which completes the verification. Now we'll verify tan squared x plus 1 equals secant squared x at x equals pi over 4. Rewrite tan squared x plus 1 equals secant squared x. Plug in pi over 4 for x. Rewrite the tan and secant ratios in terms of sine and cosine. Both cos pi over 4 and sine pi over 4 equal root 2 over 2. For each fraction, multiply the numerator by the reciprocal of the denominator. Simplify. Simplify further. The result is 2 equals 2, which completes the verification. In part F, verify that 1 plus cotan squared x equals cosecant squared x, and tan squared x plus 1 equals secant squared x are identities graphically. Make sure the calculator is in radian mode and use the settings shown. Draw the graph of y equals 1 plus cotan squared x. Now draw the graph of y equals cosecant squared x. The graphs are identical, so 1 plus cotan squared x equals cosecant squared x is an identity. Now we'll move on to the next identity. Draw the graph of y equals tan squared x plus 1. Now draw the graph of y equals secant squared x. The graphs are identical, so tan squared x plus 1 equals secant squared x is an identity.